So my next guest today is Don Migley. He's the sales manager for Impossible Objects. Welcome, Don. Nice to see you.
Great to see you, Trevor. Always a pleasure. It's great to be here.
So tell me what impossible things you've been doing recently.
Wow, it's been interesting. Year 3 here at SMTAI, and you know, I look at it as year 1 was education. As much as we're printing tooling, pallets, jigs, fixtures that have been used for decades, we're doing it in a new fashion, right? So there was a lot of time spent just getting people accustomed to the way we're doing it. Mm-hmm. Year 2 was wildly exciting because we saw partner companies that we had collaborated with solutions on. And that was great experience. Mm-hmm. To have folks come up and say, well, I recognize that. And talk about, you know, again, collaborating so we were able to alleviate some pain points that they may have had. Mm-hmm. And this year is really just about our evolution and growth. And you know, we've been fortunate to win a couple of global technology awards, and we as a company we print parts as a service, but we also manufacture and sell the machine, and we've been recognized for both, which is really great validation for the path.
I mean, it really is quite an astonishing process. I mean, it's very fast as well, you know, it's much faster than your traditional 3D printing system.
It is. It's unrivaled. I mean, we estimate right now that we're probably 15 times faster than the next fastest additive technology, and it's we're almost approaching injection molding type speeds. Our latest machine can print 11,800 cubic centimeters an hour.
Oh, that's insane.
So off the charts. It's, you know, we've said this before, and it's become a bit of a tagline, but it's the difference in a human sprinting down a F1 straightaway and that race car next to him.
Yeah,
I mean, that's really what we're seeing.
Incredible. The other thing you've done is you've also got up in size, because when we first spoke, the first product you showed us was this one here.
Yeah.
Or this size here, should I say.
Yeah, absolutely. So when we first met 3 years ago, this was about the largest single piece we could print.
Right.
And on our new machine today, that's a little different.
It's a little bit bigger, isn't it? Yeah.
Roughly about 4 times the size. So our evolution since we first met has been and really going back to speed. With our original machine, a pallet of this size took close to an hour to print.
Right.
With our new machine, this pallet takes about 6 minutes.
6 minutes?
Yeah. So we do still have to heat and press this, but we almost talk more in throughput now. Right. The first one after the full process might take a couple of hours. The second one's coming out in 5 or 6 minutes.
So what's the turnaround for a customer who's placing an order? I mean, he gives you a Gerber file, presumably.
Absolutely.
You work off of that, and how quickly do you turn it around?
Yeah, you know, like anything else, it's supply and demand. Unfortunately, we've been busy, but I would say typically within 2 weeks do they have a first article in their hand.
Okay.
Design complexity can always impact that. If we're doing the design work, that's typical. If they have a file already designed or a part already, tool already designed or pallet, it's typically closer to within a week.
Right.
Now, we are printing parts regularly off this new CBAN 25 machine today. Within the next couple of months, this will really change that dynamic quite a bit. I mean, our capacity will increase so dramatically that we will be bringing more of the true advantages of additive to the market. I mean, when this printer is fully up and running, now fortunately the first few machines are spoken for, so those are being built now.
Yeah.
But when we're deploying this machine as a service, those turnaround times will dramatically reduce.
I see. Okay, got it.
And that's, I mean, we're excited truly about bringing all the known benefits of additive manufacturing and 3D printing to this market.
Yeah, yeah. Well, I mean, it's certainly, you know, there's certainly a big need for it, you know, certainly in the tooling side. Impossible Objects is also really a materials company.
Yes.
So talk to us a little bit about the composites, the materials that you've got in here, and how you developed them.
You know, you're absolutely right. I mean, we started identifying true composite material sets that would have wide-ranging application. Mm-hmm. So we've succeeded in aerospace, incredibly strong, lightweight parts. Same with automotive. Sustainment, defense projects where you have a 70-year-old B-52 in the air that needs a wire holding bracket that's light and strong and very quickly.
Right, right.
So markets like that have been very, very receptive to the process, quite frankly. But on the materials side, carbon fiber peak is our bread and butter, if you will. I mean, we have 4 commercially available materials now. Carbon fiber nylon 12, carbon fiber peak, fiberglass nylon 12, and fiberglass peak. Now, in this market, the material sets have been great because we have both insulative and conductive.
Right.
So with the fiberglasses, if we're doing bed of nails, fixturing, things like that, we're able to achieve that. But also, as we know, ESD compliance is so critical in this space.
Absolutely.
And that conductivity of that carbon fiber ensures that we're ESD compliant.
Great.
So, but we are, there's not a day that goes by that it's not a continued exploration in terms of material science. Our process is so unique that we aren't as restricted as other processes. We're not heating and extruding a filament through a nozzle. We're actually bathing a matrix material of either carbon fiber or fiberglass in a polymer,
Right.
and fusing those together.
Yeah.
So if we can get a web of matrix material in a powdered polymer, in theory, we can create a recipe to print that.
Right.
So we have had success in printing Kevlars, ceramics, elastomers, again, kind of endless.
You've also been experimenting a bit with conductive inks.
Absolutely. One of the more exciting, primarily research and early stage at this point, but we have been able to use conductive inks to print conductive traces within our parts. So early stage, primarily used for health monitoring of the structural integrity of end-use parts, but a lot of paths that could take that are wildly exciting.
Right.
So very early stage, but truly.
It's certainly an exciting product. But I mean, final question, I would think, Don, how sustainable is it?
Great question. It's the polymer powders we use are continually cycloned up and reused in our process. So that's fantastic. I mean, we're reusing that polymer constantly throughout the process. Our matrix materials, whether it be the carbon fiber or the fiberglass, are recapturable, but not for our process. And reason being is we do bead blast away unfused fibers, and then those become chopped fibers.
Right.
Our process, we prefer long fibers so that you just have a stronger part throughout that geometry. So absolutely recapturable for other processes.
So you just have to repurpose it for something else.
Absolutely right. So polymers, we recapture. The unfused fibers that are broken away will be for other processes.
Yeah. Okay, great. Well, you've certainly got a very innovative, not just a product, but the system that you're using to manufacture it as well. So congratulations, Don. Your awards are certainly well deserved, and I want to thank you for coming in and bringing us up to date today.
Thanks so much for having us. And once again, the awards have really validated both paths we're on, so we're greatly appreciative.
Excellent. Okay, thank you.
Thank you, Trevor. Always a pleasure.
Okay.